Okay, we do another formal proof in this video, although it's something a little more fun and complicated. Pause your videos and see if you can figure out this proof. Okay, let's start talking about it. The first thing I notice is I get no premises here. So this thing must be at first order validity. This must be a logical truth of first order logic if I can prove it from no premises. So what am I going to do? Well, the next thing I need to do is look at the main connective of my conclusion. After all, I have no premises. The conclusion's the only thing I can start looking at here. And I notice that this is a wide scope negation symbol. So that tells me what to do. If this, depending upon what symbol this is, I might do different things here. There are some first order validities with a wide scope arrow, and I should sketch out an arrow intro proof. There are some first order validities with a wide scope universal quantifier, and I should sketch out a universal intro proof. But of course, for the majority of these things, what we're going to do is a reductio proof, and especially if there's a wide scope negation here. So my first step is to put this, let me see if I can advance my slides here. Now we're going. I'm going to put my sentence, the formula inside the scope of the negation symbol up in a subproof, and my goal now is to prove a contradiction. Now my main connective is a universal quantifier, and I'm going to have to instantiate that. So that you already know. If we also had an existential quantifier somewhere up here, I would need to use the existential first, but all we've got is a universal. So it's sort of a funny situation. Usually something else in the proof tells you what letter to instantiate this for, and it's wrong to just jump in and instantiate it for A or B or E or whatever. But in this case, there is nothing else happening. And so hopefully you just try to instantiate it for A to see what you could do, because really there's nothing else guiding you. And indeed, this is the right plan. Now that we're here, this is interesting. If you do a truth table for this thing, you'll see that it's a tautological falsity. So this sentence can prove a contradiction. This sentence is contradictory. Eliciting that contradiction is sort of tricky. And this is the place where I'm wondering if people got stuck or not and could really figure out what to do. I'm telling you, this is a contradiction. You can do it. So if you didn't get this far, pause your videos and see if you can now prove the contradiction symbol from this sentence on line 2. If you did get this far, if you got farther, great. Let's just keep going. You have to just try some things out. At a certain point, well, there's two ways to proceed. One is if you had the sentence P or not P, you know, the excluded middle tautology, you could do proof by cases, because in either case, you're going to prove a contradiction. In the P of A case, you could do arrow elim and prove not P of A, and then that would get you the contradiction. In the not P of A case, you could do arrow elim or biconditional elim going the other way, get P of A, and that's a contradiction. So one way you could have done this, sort of the brute force method, would be just to prove that excluded middle, P or not P, you know, P of A or not P of A, and then use proof by cases in order to get the contradiction. There's a much more efficient and elegant way to do it, but don't worry if you didn't see the solution. You only need to see it once, and then you'll get a sense of how to deal with these kind of patterns. What I do is I just assume either side. I just pick the first side, but it doesn't matter which. Once I start thinking about P of A, then I can do biconditional elim to get the opposite. And that's impossible, of course. That's a contradiction. So what, in a sense, I proved is P of A cannot be true. And by reductio, that means not P of A has to be true. But the trouble is not P of A also cannot be true, because I'm just going to do biconditional going the other way. So it's very similar reasoning to that excluded middle disjunction, except I don't even need to bother proving the excluded middle. I can just think about each case individually and show how impossible this is. I get a contradiction here, and then that's enough to justify my contradiction on line 8. And of course, that finishes the reductio. So what you can see is basically this sentence is contradictory, or it's paradoxical. So, you know, it's impossible for A to have property P. It's impossible for A not to have property P. So this is a standard structure of a logical paradox. Okay, thanks.